that smaller. Close that. And I think that is it. Okay. So we are on page 3. Get some lights here. Big turnout today. Hello, I appreciate you all. Okay, atmospheric pressure occurs because air has mass. Okay, so pressure is the gas particles pushing on things, and it is because air has mass, and those particles are attracted by the Earth's gravity. It is the amount of force exerted by the column of air that exists over top of a given area. Pressure is equal to force over area. So if we look at the little picture down below, what you can actually see is there's all of these gas molecules reaching all the way up to the top of the atmosphere. And because they have mass, they just push down on the Earth or whatever else is in the way. Okay, so any liquid or solid or anything, they just push down upon it. Okay, and atmospheric pressure is, do you guys know the value at sea level? 1 ATM, and ATM stands for atmosphere. Do you guys know that in millimeters mercury? 760 millimeters mercury. And that's also equal to 760 torr. Good morning. Okay, atmospheric pressure. What would happen to it as you move to a higher elevation? So let's say that there was now a hill here, and you were now at the top of that hill. What would happen to the atmospheric pressure? It would be smaller, it would decrease. Why? Because there's less particles pushing down, right? There's simply not as much air on top of you if you're standing at the top of the hill. Does that make sense? Yeah? Cool. Okay. Atmospheric pressure decreases as you move to higher elevations because the mass of the column of air decreases. The column of air is simply shorter. And contains fewer molecules. Good morning. Column is shorter as you go up, and so it contains, oh my God, why did I write it down? Because it's like right here. Oh my goodness, fewer molecules. Okay, less mass, less force, less pressure. Yay, okay. Yes. Yeah, and that's going to be a lot more because, of course, you've got liquid pushing down on you, and the concentration, per se, of a liquid is much higher than the density of a liquid is much greater than the density of a gas. Yes? No, you can look at it on Teams, okay? We're just going to push through this. I know. Kind of sucks, but there we are. Okay. Barometer, because we just got 25 minutes, and we're just going to go. A barometer is a device for measuring, this is page 4, pressure. I might do that at the end, yeah? A glass tube from which the air has been removed. So in other words, we have a vacuum. Okay, here's our vacuum. and it is inserted into a dish of mercury. So we have mercury in here. And then the air pushes down on the mercury. And what happens when the air pushes down on the mercury? The level of the mercury, where does the mercury go? It goes up the tube. Yeah? So literally, when we are measuring pressure in millimeters of mercury, we're saying here's, 5 millimeters, 6 millimeters. That's literally the height that mercury goes up that tube. Okay? So those are millimeters, literal millimeters of mercury. An increase in pressure forces the mercury to rise inside the tube. As the pressure drops, so let's say we're having a low pressure system, what happens to the mercury? It drains out of the tube. And what would happen to the height of the mercury if the mercury is now draining out of the tube? It's going to go down, okay? So decreasing the height of the column. If the barometer on the right, this one here, were at sea level, what would the height be in centimeters? Ooh, that's a good question for you. See if you can figure that out. We're at sea level. What would the height of that column of mercury be in centimeters? Any guesses? Sorry? 7.6. How did he know that? Because we are at sea level, therefore the pressure of the atmosphere, PATM, that's our pressure of the atmosphere, is 760 millimeters of mercury, which literally means that the height is equal to 760 millimeters, which means that in centimeters, that would be equal to 776. 76 centimeters. Did I get that right? Yes. Okay. Did I do that right? Yeah. Okay. We just moved the decimal place one place, right? Yeah. Okay, cool. Barometers literally measure the millimeters of mercury. Oh. Yeah. In other words, the height of the column of mercury in millimeters. I should put an IE there, IE. Okay. Some books use inches of mercury if they are published in the States. We're not going to worry about that because we are not in the States. Now, you can have a barometer. The barometer measures the pressure of the air, of the atmosphere, because it's just open to the air pushing down on it. We can also have a manometer, okay? And a manometer is a device that measures the pressure of contained gases. So instead of measuring the atmospheric pressure, it measures the pressure of a contained gas. And a simple manometer simply consists of a U-shaped tube, U-shaped tube of glass filled with some liquid. Typically the liquid is mercury because it is of high density. But you could use water, you could use anything. Now, in the figure to the right, we see a U-shaped tube with some liquid, okay, piece of glass tube, and both ends are open to the atmosphere. So the pressure in B and the pressure in A are what can you say about them? They are the same because it's both atmospheric pressure. Now that's not much use to us for measuring the pressure of a contained gas because we don't have a contained gas. This is just showing you how one works. So here we have an open end manometer. So one end is open. Here we have the open end. Okay, you can see it's open there. But the top of the other one is closed. Okay, and what we have done is into that closed area, we have inserted, and there would probably be like a little tube leading in there with a little valve that you could, you know, close it on or off. Okay, but we're just not drawing that. We're just assuming that there's a tube here and it's got some gas in it. So in here, we have a gas. Now, atmospheric pressure is pushing down on the open end, whereas the gas is pushing down on the closed end. Yes? Which is higher? P gas or P of the atmosphere? Which is higher? Is greater? The gas, because it is pushing down more. How much more is it pressing down? It's pressing down more by a factor of H. Yes? Which is the height between the two ends of the mercury. So this means that as long as you know the atmospheric pressure, you can calculate the pressure of the gas by figuring out what the height difference is there. So here we have a case where, in this case, the atmospheric pressure is greater than the pressure of the gas. There's a lot of explanation on the left-hand side, but I don't think we need to go through that all, do we? No, probably not. Okay. So let's do some calculations here. what is the pressure of the gas sample in the manometer shown below? First of all, is the gas exerting more or less pressure than the atmosphere? It's exerting more pressure than the atmosphere. So we need to figure out how much more. How would we calculate how much more, given all the things we have written here? We would have to take H2 minus H1. Yes, absolutely. So we can find it by finding the difference in the height of the two columns. So delta H is H2 minus H1, and we are told that H2 is 77.8 and H1 is 50.6. So we have 77.8 millimeters minus 50.6 millimeters, and that is equal to, I'm going to cheat, 17.2 millimeters of mercury. It's not right? Oh, okay. 77.8 minus 50.6. Is it 27.2? Okay, whoops. Sorry about that. Yeah, that sounds better. Okay, so 27.2, excellent. So that's a typo in your book, in your answer key. So if you are at home doing this, in your answer key it says 17, it should say 27.2, not 17.2. Okay. So what's the pressure of the gas? Oh, I'm wrong. I'm wrong. That shouldn't go there. This should be 77.8 minus 50.6 is equal to 27.2 millimeters of mercury. Is that the pressure of the gas? No, it's not the pressure of the gas. What would the pressure of the gas be? Or how would you calculate it? Yeah, it's going to be the pressure of the atmosphere plus 27.2 millimeters mercury. And so what we have then is we're told that the atmospheric pressure is 760.0 plus 27.2 mmHg, which gives us 787.2 millimeters of mercury. Yes. Yes. What that means is that from here to here, the height is 50.6 millimeters. Like you literally measure it with a ruler. Yeah? And so the height from here to here, good question, is literally whatever it was, 77.8 millimeters. And you would have markings on here to like help you do that, right? Yeah. Okay. What is the pressure of the gas in the manometer shown below? Well, in this case, your gas is exerting less pressure. So H1 is 117.8 millimeters. And H2 is 67.5 millimeters. So delta H is 117.8. It doesn't matter which way you do it. You can either subtract or add. I always like subtracting just because it makes my life a little easier. 67.5, and so we get 50.3 millimeters of mercury. So the gas exerts 50.3 millimeters of mercury. Is that more or less than the atmosphere? Less than the pressure of the atmosphere. And so we would take the pressure of the gas would equal the pressure of the atmosphere minus the 50.3 millimeters of mercury. All right, so let's figure out what that is. Oh no! This time they gave us pressure of the atmosphere in kilopascals, which means that before we do the subtraction, we need to do a conversion. And you can choose which way to go. You could either convert them both to kilopascals, or you could convert them both to millimeters of mercury. Because we've already got this in millimeters of mercury, let's just convert that way. So we have P of the atmosphere is equal to 99.75 kilopascals times, and we have 760 millimeters mercury per 101.3 kilopascals. Oh, we're going to say 760.0 there just because we can. And that gives us 748.4. 748.4 kilopascals. Millimeters mercury, mmHg. Okay, so there we go. So the pressure of the gas now is 748 millimeters of mercury, 0.4 millimeters of mercury minus 50.3 mmHg, which is equal to 698.1 millimeters of mercury. Is good? Excellent. There are some manometer problems here. Why don't you try a couple of them just to wrap up the last, well, we only have 2 minutes, don't we? So why don't, oh, I don't really want to assign you homework. It would be okay if I assigned you like maybe just like the odd questions, because there's not very many. So just do the odd ones. 1, 2, 3, 4. Is that too much? Is it okay? Okay, just do the odd ones. There we go. And that's it. We'll leave it there for today. Thank you guys so much. You're welcome.